Okay, this is very similar to the question we did previously. In fact, it's almost exactly the same thing, only that they changed some few things here. So let's read the question. It says, if 6 workers can build 4 cars in 2 days, then how many days would it take 8 workers to build 6 cars? How many days would it take 8 workers to build 6 cars? So the things we are interested in here actually is the workers, the cars, and the days. So 6 workers build 4 cars in 2 days, and 8 workers build 6 cars, but want to know the number of days is going to take the 8 workers. Alright, this is how we go about it. Now from the first statement, so this is statement 1, while the next statement is statement 2. So from the first statement, we are told that 6 workers, so 6 workers, they build 4 cars in 2 days. And then from the second statement, so from statement 2, we're told that 8 workers, they build 6 cars, but we do not know the number of days it takes them to build 6 cars, and that's what we want to know. So we're going to derive this solution just based on the model we'll form from the relationship going on between the workers, the cars, and the days. Alright, now how do we go about solving this? Just like the first problem we did. So what you'd observe here is I'm going to call my workers, I'll let W to be the variable that represents workers, and let C be the variable that represents cars, and D be the variable that represents the number of days. So again, like the previous video, the number of workers, the relationship between the number of workers, so I want to establish a relationship between W, C, and D. So since the higher the number of workers, the higher the number of cars produced, and the lower the number of workers, the lower the number of cars produced. So that implies that there is a direct relationship between W and C. But then the higher the number of workers, the lower the number of days it will take them to produce a car, and also the lower the number of workers, the higher the number of days. So you can see the inverse relationship. So there's an inverse relationship between W and D. So that's going to be the reciprocal here. So to solve this, I have to change this to equality sign to be able to solve that, because it's not an equation. So when you change that to an equality sign, there should be a constant of proportionality. So to represent this, so this is KC all over D. So these two statements, they are equivalent to each other. So now my bone of contention is, how then do I find K? Now to find K, I'm going to lay credence to information I'm given here. So it says when W is 6, my C is 4, and my D is 2. So when W is 6, so this is K, which is what I want to find. My C is 4 divided by my D is 2. So to find this, so this is the same thing as, so when you cross multiply, so you have 2 times 6, which is 12, equals, so you have K times 4. So you divide both sides by 4 to find K. So this goes off, and then 4 in 12 is going to give you 3. So your K equals 3. So my K equals 3. So I've been able to establish a relationship between W, C, and D based on the first information I'm given. That is, my W equals 3 times C all over D. So I'm going to use this model to solve this problem. So now what we have here is, so let me rewrite it here. You have W equals 3C all over D. This is what I have. Now for this question here, I've been told that my W equals 8, and so let me not confuse things. My W is 8, and my C, so this is C is representing the number of cars. My C is 6, so I want to find D. So my W is 8 equals 3 times my C is 6, so this is 6 divided by D. So I want to find D. So to find D, you cross multiply. So this is going to be 8D equals 3 times 6. That's going to give you 18. So to find D, you divide both sides by 8. So this goes off, and then here you have 2 2 in 8 is going to give you 4, and then 18 in divided by 2 is going to give you 9. So your D is going to be 9 all over 4. So answer is 9 all over 4, 9 all over 4 days. So that's 9 all over 4. Yeah, so this is our answer, 9 all over 4. And that completes the problem. Thanks for watching.